And our next speaker for the day is Mr. MoonSoo Kang from Samsung. To introduce him, Mr. MoonSoo Kang is the head of team market strategy team foundry in Samsung Electronics. So basically, he's going to be telling us from a Samsung perspective how they look at the ESD industry globally and in India, and also share his perspective on the foundry business itself from Samsung. We're very privileged to have you here today, sir, all the way from Korea. Thank you so much for sparing your time. And over to you, the floor is yours.
Hello everyone, my name is MoonSoo Kang. I am Senior Vice President of Market Strategy at Samsung Foundry, and I am responsible for Samsung Foundry's technology roadmap and strategy. I am honored to have a chance to introduce Samsung Foundry to this prestigious forum today. Today, I will first talk about the semiconductor industry and foundry market briefly. Then I will introduce you Samsung Foundry's technology leadership, showing what exciting technologies we have developed and are developing currently. Then finally, I will present Samsung Foundry's ecosystem and partners. We all have witnessed a dramatic growth of the semiconductor industry over several decades. Until about 10 years ago, around 2010, the growth of semiconductor market was driven by PC, personal computers. Every year, the PC sale steadily increased until around 2010, but it was saturated around that time. From around 2009, the smartphones became the driving force for the semiconductor market growth. Smartphone sale increased remarkably year over year for about 10 years until 2017-18, but it was again slowed down and remained stable. Around that time, the era of data began, and the amount of data traffic is exploding. We believe data business will be the next growth engine for the semiconductor industry, at least for this decade. This trend is even more accelerated because of COVID-19 pandemic, as more and more people rely on telecommuting, online learning, and in-home entertainment. Let's see how semiconductor market today looks like in terms of applications and products. Today's semiconductors are basically mimicking the functions of a human brain and sensory organs. The human brain has important functions like thinking, in other words, processing information, collecting information, storing information, and transporting information. Collecting information is handled by semiconductor products like image sensors and other type of sensors like LiDAR and DBS. Collected information is moved to a different part of the brain, and such functions are handled by communication products like modems, transceivers, etc. Then thinking or processing information is handled by chips like CPUs, GPUs, APs, and NPUs. Finally, storing information is done by various memory products like DRAMs, flash memories, and solid-state drives. Today's semiconductor market is made of such diverse products, and foundries are playing an important role with all such products, possibly except memory products. In old days, most of semiconductor companies were IDMs, integrated device manufacturers. They design and manufacture their own semiconductor chips. However, in today's semiconductor industry, a major portion of semiconductor manufacturing, especially with advanced technology nodes, is done by a small number of foundries. As the semiconductor industry continues to grow, the foundry business will rapidly grow as well. The total foundry market size was about $86 billion in 2020, will be over $100 billion this year, and will reach around $180 billion in 2026, more than double of 2020 market size. The mobile segment is today's biggest segment in total foundry market. It is expected to be still the biggest segment in 2026, but closely followed by HPC AI segment. HPC AI segment will be the most rapidly growing segment, at least for the next few years. So, mobile and HPC AI applications together will drive the growth of the foundry industry for the next few years. As you all know, for several decades now, the semiconductor industry has been relentlessly pursuing miniaturizing transistors and interconnects on silicon, as initially projected by Gordon Moore. Such relentless area scaling, known as Moore's law, has been fueling revolutions in computing and electronics to this day. However, silicon feature size scaling, represented by gate pitch and minimum metal pitch, alone is not enough. As demands for computing power have increased, the number of transistors in chips have been rapidly increasing as well. Thus, chip sizes keep increasing even with good Moore's law type scaling. In case of computing power hungry GPUs, the chip size has continued to grow, already approaching the full radical size. Ever-increasing chip sizes and transistor counts result in increased chip design costs and manufacturing costs. Thus, more scaling alone can no longer provide a complete solution. Thus, we at Samsung Foundry are actively developing smart large scaling, also called DTCO, and system level scaling, STCO, in addition to traditional Moore's law type pitch scaling. Technology innovation and taking technology leadership is nothing new to Samsung. Samsung has a long and well-established history of technical leadership with the logic technology. Samsung introduced high-K metal gate process first time in foundry industry with its 28 nanometer node. Samsung was the first foundry to introduce FinFET technology with its 14 nanometer node. Samsung's 10 nanometer logic process node was first in the whole industry, including both foundries and IDMs. We began mass production of EUV process first time in the world with our 7 nanometer technology node. Our next innovation is a completely new device architecture called gate-all-around transistors. We are proud to say that the world's first gate-all-around product is ready for production in 2022. EUV technology is an advanced technology with a light source of 13.5 nanometer wavelengths, which is extremely short compared to ARF excimer wavelengths of 193 nanometers. With much shorter wavelengths, EUV enables superior pattern fidelity and CD controllability, as shown on this page. On top of that, EUV enables the use of only one mask exposure instead of multi-exposure with ARF, thus allows reduction in process steps and complexity. The Samsung Foundry started world first mass production of EUV wafers with its 7nm technology in the third quarter of 2019, and the manufacturing facility has been gradually increasing its productivity. Continuous EUV enhancement enables affordable chip scaling to 5, 4, 3nm technologies and beyond. Recently, scaling trends has been slowing down due to increasing technical difficulties. As an answer to this, Samsung Foundry is now developing a new breakthrough device structure called Gate-All-Around transistors named MBC FET, Multi-Bridge Channel FET. With GAA architecture, where the gate surrounds all 4 sides of nanosheets, the effective channel width of MBC FET increases compared to FinFET. GAA MBC FET also supports various effective widths by patterning the size of the nanosheet. FinFET, on the other hand, can only provide a quantized number of pins. Furthermore, the 4-sided gate structure can improve the electrostatic control of the channel. With better short channel effect, GAA enables further gate length scaling and lower operational voltage. Because of its large effective channel width and the low power provided by better short channel effect, GAA MBC FET supports faster speed with lower power consumption. GAA MBC FET is a breakthrough that will push the boundaries of a FinFET technology. And good news is that our 3nm GAA technology progress is on schedule, and the first GAA product will be out in 2022. Now, let me introduce a short video on GAA MBC FET to help you better understand the technology.
Whenever semiconductor technology faced challenges, there has been a guiding light to help navigate the maze. Evolution of transistors is a major component of technology development. Planar transistors have been used for generations with voltage scaling to save power. However, short channel effect ultimately limited usability. FinFETs were the solution and made further voltage scaling possible. Unfortunately, limitations are faced again. For ideal electrostatics, the channel needs to be fully surrounded by the gate. This is known as gate-all-around. Typical GAAs are nanowires. However, integration complexities of nanowires outweigh the benefits. This led Samsung Foundry to create a unique version of GAA with all the advantages but minimal complications. Samsung Foundry proudly introduces our multi-bridge channel FETs. MBC FETs consist of multi-stacked nanosheets. One advantage of MBC FETs is that additional area is not required to improve speed. FinFETs need fins to be laterally added, while nanosheets can be vertically stacked. MBC FETs are compatible with FinFET designs. Designers can replace FinFETs with MBC FETs without changing the footprint. Performance can also be improved without area increase. MBC FETs are the most advanced technology that provides solutions from low power to high performance applications, including AI, autonomous driving, 5G, and high performance computing. With MBC FETs, Samsung Foundry will be the guiding light for the future of the semiconductor industry. Samsung Foundry.
I hope you enjoyed the short video on GAA. GAA is a great example of technology innovation we are doing to make smaller, faster, and more efficient transistors. However, I briefly mentioned earlier that may not be enough. So, Samsung Foundry is developing system technology co-optimization (STCO) solutions as well. One important technology is a heterogeneous integration. Now, let's move on to how heterogeneous integration can mitigate increases in development cost and improve overall chip performance. As more features are added onto a chip, the die size increases even with good Moore's law-like scaling. Also, using one single process node for all design blocks with different functions is becoming less and less efficient. By partitioning a large die into smaller chiplets and adopting an optimal process for each one, it becomes possible to improve the overall yield and reduce manufacturing cost. For example, certain interface IP blocks do not benefit from the most advanced process node in terms of area scaling or performance. By using a mature process node or optimized specialty process for those IPs, we can not only reduce manufacturing costs, but also improve block performance. Another aspect we can consider is modular design and manufacturing. In other words, reusing component chiplets. A significant portion of IP modules can be reused as chiplets. Only the remaining portion of the chip can be redesigned and manufactured as a new chiplet through heterogeneous integration. This way, we can significantly reduce design, development, and manufacturing costs. Heterogeneous integration can also enhance the performance of chips. With conventional two-dimensional designs, signal paths between design blocks can be several millimeters long. With three-dimensional integration, in which one chip sits directly on top of another, signal paths can be reduced to several micrometer lengths, resulting in greatly improved latency. In addition, finer interconnect pitch in 3D integration enables extremely high bandwidth, resulting in higher performance. To enable heterogeneous integration, Samsung Foundry built advanced package platform made of 2.5D, 3D, and 3.5D solutions. In 2.5D solutions, multiple chips are connected on top of an interposer. With 3D solutions, two chips are vertically stacked and directly connected. A 3.5D solution is a combination of 2.5D and 3D solutions. We built our advanced package platform with our eco-partners like OSATs, so our platform is truly an open platform. We call our 2.5D silicon interposer-based solution iCube. Our 3D vertical chip stacking solution is called xCube. In addition to advanced heterogeneous integration solutions like iCube and xCube, Samsung Foundry has a comprehensive foundry package solutions, including more conventional packages. Our package solutions support customer needs in diverse applications like mobile, automotive, and high-performance computing. Our mobile package solutions focus on providing thinner, smaller, and lighter packages based on our extensive experience in mobile business. Our automotive solutions' first priority is the safety and reliability. Our HPC solutions focus on enabling high performance and high bandwidth to integrate ASIC, memory, HBM, and high-speed I/Os like SerDes. Now, let me switch gears and talk briefly about our foundry ecosystem called SAFE, the Samsung Advanced Foundry Ecosystem. When we first announced ourselves as a pure-play foundry, what we were missing was an ecosystem for our customers. However, we quickly realized that building a comprehensive ecosystem is critical for our customer success and also for our own success. So we began building and expanding our SAFE ecosystem. SAFE is made of various elements. On design platform side, we have SAFE IP, which provides numerous high-quality design IPs for each design. SAFE EDA, which enables various design and simulation tools and methodologies for chip design. SAFE DSP, which provides flexible design services and partnership. And SAFE CDP, which provides efficient cloud-based design platform. On the packaging, assembly, and test side, we team up with external OSAT partners to provide comprehensive yet flexible services to satisfy customers' diverse needs. With SAFE ecosystem, combined with Samsung Foundry's most advanced technology and manufacturing capability, Samsung Foundry's customers can quickly convert their innovative ideas to successful products with minimal efforts. IP readiness is fundamental for our customers to be able to start designing products on our process technology. We have built an extensive IP portfolio with our SAFE IP partners across multiple technology nodes. Samsung Foundry's extensive IP portfolio begins with foundation IPs like standard cell libraries and memory compilers. On top of that, SAFE IP includes numerous types of memory interfaces, DDR, LPDDR, GDDR, and even high bandwidth memory interface, HBM. High-speed interfaces like PCI Express, MIPI, USB IPs are all available, and high-speed serial interface, SerDes, which is critical for network and high-performance computing, are also provided. To support and enable successful heterogeneous integration, SAFE IP also include various die-to-die interface IPs. In today's rapidly changing market, many customers have brilliant ideas to build great chips, but sometimes they do not have expertise or experience in designing chip from scratch to completion. To help such customers, we have built an extensive network of design solution partners. Our design solution partners can provide flexible design services to our customers in need of some level of design help. Samsung Foundry has 12 design solution partners worldwide across different continents in North America, Europe and Middle East, Asia, and Korea. Samsung Foundry not only provides manufactured silicon wafers to our customers, but also do comprehensive turnkey business, including packaging. Our package turnkey business is done by Samsung Foundry's internal packaging and assembly facilities, as well as by numerous OSAT partners. Samsung Foundry provides truly open package ecosystem. When we first announced ourselves as pure play foundry, what we were missing was an ecosystem for our customers. However, we quickly realized this shortfall and began expanding our safe ecosystem. This is a snapshot of where we are now. We have 9 cloud partners to serve cloud infrastructure, 12 DSP partners to provide design services, and 18 EDA partners to provide EDA solutions with more than 80 EDA tools. Furthermore, we have 53 IP partners, meaning that our total available IP count now exceeds 3,600, as well as 10 OSAT partners supporting 21 packaging platforms. I am certain that we have successfully developed a strong ecosystem to support our customers, and I am confident that SAFE will continue to grow with its partners by providing an open ecosystem. Now, I have reached the end of my presentation. Samsung Foundry has a strong portfolio of process technology, packaging technology, and design platform. With that, Samsung Foundry provides complete foundry solutions to its customers for the future of the semiconductor industry. Samsung also provides one-stop solution to bridge customers' ideas to successful products. We have built many customer success stories with our product-proven technologies and solutions, and will continue building more success stories for the future to come. Thank you for your attention, and I hope you all stay well during these times.
Good afternoon again, and thank you, Mr. MoonSoo Kang, for that really informative video covering all aspects of computing, starting from the business. We are now going to take a short break, and this is the end of the first session for today, or primarily the inaugural session. The next session is going to start at 1:15 p.m. So we are going to have a break from now until 1:15 p.m. You can use the networking lounge, so attendees are informed that they can use the during this break. We encourage you to do so and connect with each other.